Hi everyone, in this lesson we're going to be looking into the start of chapter 4 in your textbook. We're going to be looking at common factoring. First, let's try and tie our common factoring concept to the previous unit we've just finished up, looking at quadratics. So we've got a quadratic here. It's y equals x squared plus 4, and we're going to determine the direction of opening, the vertex, and the zeros. Okay, so here we go. First of all, let's do our direction of opening. When we're looking at our direction of opening, we're just looking for our a value, which is right here. In this case, our a value just equals 1. So we'll say for question A, what's the direction of opening? Well, it opens up, and we know that because a value equals 1. It's a positive number. It being a positive number tells us that it opens up. If it was a negative number, it would be opening down. Okay, our next question, B, asks us to find the vertex. Well, anytime we've got something in standard form to find the vertex, we've got an equation for the axis of symmetry. That's where we're going to start, negative b over 2a. Well, b would be the value right here. So b is equal to 4. And of course, there's c value just equal to 0. There's no c value there. So let's sub into our formula. Negative b would be negative 4 over 2 times 1. So our x value is going to be negative 2. Negative 4 over 2 is negative 2. Now if we want to find the corresponding y value, we need to sub into our equation. So let's do that. Our equation is y equals x squared plus 4x. So anywhere we see an x, we're going to sub in a negative 2. So negative 2 squared minus 4 times negative 2. Negative 2 squared is 4. Negative 4 times negative 2 is going to give us positive 8. Oh, no, sorry, that's plus 4. My mistake. I was thinking something was off there. So 4 times negative 2 is going to give us negative 8. So our answer is going to be negative 4. So what's our vertex? Well, our vertex is going to be at negative 2 for our x-coordinate, negative 4 for our y-coordinate. Finally, for C, the zeros. Well, that's kind of tricky, isn't it? Because this is in standard form. It's not in factored form. So that actually makes this one a little bit tricky. So we say, okay, we need to change this. Need to change to factored form. And that's really going to be the crux of what we're learning right now in this lesson and further in this unit. How do we take something that's in standard form and turn it into factored form? Because factored form is going to be really useful to us in telling us the zeros, which actually turn out to be super important in terms of anything that has a quadratic equation, which is tons of stuff in the real world acts like quadratic equations. So we'll say, okay, what if it was in factored form? It would actually look like this. And we can check that if we were to multiply the x through the brackets, we would get x squared and we would get 4x. So we know that that's correct because we're able to tell if we multiply through the brackets, that's what we get. So what are our zeros? Our zeros are at 0, 0 and negative 4, 0. Now how did I get those? Well, I just looked at the signs in my equation. My first one is basically x plus 0. That's why it's just written as x. So that's going to be 0. And my other one has got a plus 4 in it. That means I'm going to have a minus 4 in my actual x-intercepts on my quadratic. Okay, so we did it. But you might say to yourself, Mr. Roy, how did you know how to put that in factored form? Well, you're going to know by the end of this lesson today. That's actually the stuff we're going to learn right now. So we say, while standard form is useful in finding the direction of opening and the vertex, like we did for A and B, it's quite easy, it does not allow us to find the zeros, standard form. Too bad. If we could convert to standard form back to factored form, we could identify the zeros. And that's what we're going to practice right now. Okay, here we go. So if we want to convert from standard to factored form, we have to be able to do this thing called factoring. That's actually why it's called factored form, which you didn't know up until now. That is, we got to figure out which terms have been multiplied together to make the equation. So what we're used to doing is starting with something that looks like this. It's in factored form, and we expand it. We multiply through the brackets, and then we multiply what we get by -2, and we end up with one that looks like this one over here in standard form. So we know how to do that because we did it last unit, but how do we go backwards? Instead of expanding, how do we do factoring? So we say, okay, we're okay with that from last unit, but how do we go the other direction? How do we factor? We're going to learn how to do that today. The first step of many. So here's our first example. It says expand 3x times 2x squared plus 5x minus 1. So I see that I got that 3x out in front of the brackets. What does that mean? Well, that means I got to multiply that 3x through the brackets if I'm going to expand. We did this a lot last unit. So let's do that. Let's multiply through the brackets. 3 times 2 is 6, and x times x squared, that's going to be x cubed. We add their exponents together, right? Because regular x is just like x to the 1. Now 3x times 5x, 3 times 5 is 15, x times x is x squared, and 3x times -1 is -3x. So I've done my expanding. Now how could I undo that? How would I know how to undo that and go back to the factored form? Well, let's talk about that. So the first concept is that when we expand an expression like I just did, we're using the distributive property, right? That's what we call the distributive property. That's when we multiply all terms in front of the bracket by everything that's in the bracket. So we multiply something through the brackets. That's called our distributive property. Now when we're factoring, we're going to do the opposite. Instead of multiplying by every term inside the brackets, we're going to divide every term inside the bracket. So we'll do the opposite. We're going to divide every term inside the brackets by the same thing, by a single value. Generally, when we do that, we want to find this thing called the greatest common factor. Now, you're probably used to finding the greatest common factor when there's just numbers involved. This is something you'll have done in the past. But what happens when there's variables involved like x, right? How do we find the greatest common factor involving that? Well, we're going to practice that right now. So for our greatest common factor, it's just the number, letter, or combination of the two that all of the terms inside the brackets have in common or are divisible by. So let's actually do some examples to make this a little more clear. Let's find the greatest common factor for some things we've got here. For our regular numbers, 3, 12, and 15, this is something that we're a little more familiar with. So we got to find something that these are all divisible by. What's the biggest number that all of these numbers are divisible by? Well, they're all divisible evenly by 1. So 1 is a factor. Is it the biggest one? I don't think so. How about 2? Well, 3 and 15 aren't divisible by 2, so 2 is not a factor. How about 3? Is 3 a factor? Yeah, it sure is. 3 is divisible by itself, by 3. 12 is divisible evenly by 3. And 15 is divisible evenly by 3. Now, could there be a bigger factor than 3? No, because one of my numbers is 3. So that's as great as I can have. So 3 is my greatest common factor. So I'll say my greatest common factor equals 3. 3 is the biggest thing that all 3 of those terms are evenly divisible by. Now what if I just had like a letter, like A? Well, here's the thing. What does A to the 4 mean? That just means A times A times A times A, right? That's what A to the 4 means. Just like A to the 2 really means just A times A. So what's the biggest number we could, or biggest thing we could divide by out of these factors? Well, here's what we can do. We can say that they all have an a squared in them. They all have at least an a squared in them. They all have at least an a squared in them. And when letters are common, like they all have at least one a, we're going to look for the smallest exponent. So we say when letters are common, we look for smallest exponent. So in this case, an a squared. So what's our greatest common factor for all of these? Well, it's going to be a squared. I can divide each of them by a squared. Now, what would happen to my a to the 4 if I divided it by a squared? Let's actually move that up here just so we can see what that would look like. What would that actually turn out to be? Well, my a to the 4 is written like that. What if I divide it by a squared? That's a times a. Well, I can cross out an a on the top and an a on the bottom. That just equals 1. Another a on the top and another a on the bottom. That just equals 1. So what am I left with? I'm left with a times a. That's a squared is left over. What about my next term, a squared? If I divide that by a squared, a times a, well, everything cancels out and we're just left with 1. What if I have my a to the 5? That's a times a times a times a times a. What if I divide that by a squared? Well, I can cancel out 2 on the top and 2 on the bottom. I'm left with a times a times a. That's a cubed. So I can divide an a squared out of all of them. That's my greatest common factor. How about my last one here? What's my greatest common factor? Well, let's look at the numbers first. What's 12, 18, and 30? What's a number that divides them all? So they all divide evenly by 1, of course. They all divide evenly by 2. They all divide evenly by 3. What's the biggest one? Well, the biggest number that divides them all evenly is actually 6. So they all divide evenly by 6. So my greatest common factor is going to have a 6. But what about the variables here, the x's? Well, they all have at least one x. So I could divide at least one x out of them. So it's going to be 6x. That's my greatest common factor. That's the biggest term that I could divide evenly out of all three of those. My greatest common factor. Okay, so now that we've figured out how to find greatest common factors, let's actually try some factoring. Here we go. Let's do a little bit of factoring. My first one, negative 12x plus 4y. Okay. Well, what's a number that I could take out of each of them? Looks like they're both divisible by 4. 12 is divisible by 4, and so is 4. Since 4 is one of the numbers, that's got to be our greatest common factor. Now, what would that look like? If I pull a 4 out front, I also need to divide each of the terms by 4. So negative 12x over 4 and 4y over 4. Well, 4 divided by 4 is just 1. Negative 12 divided by 4 is negative 3. So what's that going to look like? I'm going to have a 4 out front, negative 3x plus 1y, or just plus y. You could just write that as plus y. So what I've done is I put a 4 out front, and I've divided every term by 4, my greatest common factor. So a little hint, we want the expression to be in this form. Greatest common factor out front, and in the brackets, all the remaining factors. Let's switch colors and go to our next one here. Let's ask yourselves, what's a number that can be divided, that 15 and 10 can both be divided by? You may want to pause the video here, try and come up with it yourself. Well, I noticed that both 15 and 10 are divisible by 5. And that's the greatest common factor. That's the biggest number I can get that divides both 15 and 10 evenly. Can I divide an x out of each of them? I sure can. They both have at least one x. Can I divide a y out of each of them? Yeah, they both have at least one y. Cool. Okay, so let's do it. Let's go 15xy over 5xy. and 10xy squared over 5xy. What are we going to end up with? Well, let's do the division. 15 divided by 5 is 3. And xy divided by xy, well, that's just going to equal 1. So we're just left with a 3 there. How about my other one? 10 divided by 5 is 2. The x's are going to cancel out, so there's no x in there, because x divided by x is just 1. The y's, one of the y's on the top is going to get canceled out by the other y on the bottom, so we're just left with a single y on the top, on the numerator. Now, you may be thinking like, how do I know if I got this right? How could I check this? Well, here's a little hint to make sure that you're doing this right. There should be the same number of terms in the bracket as there are in the question. So the question has 2 terms. Both of these actually had 2 terms. And so there should be 2 terms in the bracket when I'm done, in order to make sure that I've done it correctly. Now, this little step I did inside the brackets, where I take the whole thing and I divide it by the greatest common factor, we're actually going to get away from writing that whole thing because we want to be able to move a bit faster, and that gets really messy and time-consuming to write. So I actually did that to make it kind of clear what I was doing, to make it clear that I was, for example, dividing by 4 because I had multiplied by 4 to kind of even it out, and dividing by 5xy because I had multiplied by 5xy. So I didn't want to actually change what the overall equation was. I just wanted to change how it looked. I'm going to stop doing that part in the brackets because that's not really the hard part of what we're doing. And we're going to need to get used to not writing that part. Okay, so here we go. Let's have a look at C. What's our greatest common factor for 28 and 4? Well, it's always a good idea to have a look at what the smallest number is. The smallest number is 4. So you can say, okay, well, I know 4 is divisible by itself. Is 28 also divisible by 4? Yeah, sure is. 7 times 4. So I'll put a 4 out front. Do they both have an A? Yeah, they both have at least one. Do they both have a B? No. So I can't factor out the B. Okay, let's take 28 and divide it by 4. That's going to be 7. One of the A's divides out and the other A is left over. How about the other term? Well, 4 divided by 4 is just 1. A divided by A is just 1. And I can't factor out the B. So what does that work out to? 4A out front, 7A minus B. There we go. So I've factored that by dividing out the greatest common factor and putting it in front. You can kind of think about this like when we do multiplying through the brackets, we draw arrows like this to show what we're doing. You can kind of think about this the opposite way, that we're dividing out like that. Okay, so that can be helpful. That can be a way to think about it. Okay, let's have a look at our next one here. Common factor. Well, I can take a 6 out of each of them, and I can take an A out of each of them, but no more than that, just a single A, because my first one just has a single A. So 6A divided by 6A is just 1. 12 divided by 6 is going to be 2. And A to the 5, divide one of those A's out, I got 4 of them left over. There we go, we factored it. Something to remember is this. How can we check if we're right? How can we check if we're right? Well, here's what I would recommend if you're a little unsure if you got it right. Just expand by multiplying through the brackets. That's a great way to check. So if I multiply through the brackets, 6A times 1 is 6A, and 6A times negative 2 A to the 4 is going to be negative 12 A to the 5. So yeah, I got it right. So how can we check if we're right? We can multiply through the brackets. Same as we were doing last unit, just to check and see if we get to the same place where we started. All right, let's keep rolling along and try a few more of these questions. Now we got 3 terms. It's getting a little more complicated, but that's okay. That's where we need to go. What can we divide out of each of these? Now, the first thing is, what's a number we can divide out of each of them? Well, the greatest common factor, it turns out, for this is 1. a 1. There's no number besides 1 that divides any of them out. But they all have at least an a, and they all have at least one x. So I can take out both an a and an x. Let's divide them out. Well, the a divides out of the first term. One of the x's divides out, leaving us 2 left over. So x can be x squared. Our number can't be divided out. Our a is divided out, and one of our x's is, leaving us with just a single one. We could write the 1 there just for clarity right now. And our last one, our 3 doesn't divide out. Our a does, and our x does. So we're just left with 3. So this ends up being ax times x squared minus 5x plus 3. Okay, let's look at our next one. Let's go to F. Whew, this one's got lots of pieces to it. What's a number that divides 45, 15, and 60? Well, it's actually 15. 15 is the biggest number. And so it's always good to look at the smallest number in your coefficients and see if that one works. Because if it does, that would be your greatest common factor. Let's factor 15 out of each term. Let's also factor out an a, because they all have at least a single a. And they all have at least a b. So I can factor out an a out of each of them and a b out of each of them. 45 divided by 15 is 3. I factor one of the a's out, leaving me with just a single one, and I factor the b out. My next one, I factor the whole 15 out, I factor the a out, and one of the b's, leaving me with just a single b left over. My last one, 60 divided by 15, that's 4. I factor the a and the b out, so just 4 is left over. There we go. We've done our factoring using our greatest common factor. Let's go on to G. Oof, this one has lots of pieces to it. Well, what can I factor out? What's a number? My greatest common factor is going to have a 3, because I can factor 3 out of each of those terms. What about P? Well, they all have at least a P squared. So I can factor out P squared. What about Q? They all have at least a Q squared. Oopsie. Let's put in our bracket and let's divide out the pieces. 6 divided by 3 is 2. The P squared divides all the way out, so it's just multiplying by 1, doesn't change anything. And for the Q's, we divide 2 of them out, leaving us with 1 left over. For my next term, the 3 divides out, 2 of the P's divide out, and both Q's divide out, leaving us with just a single P. What about my next one? 9 divided by 3, it's going to be 3. Both the P's and 2 of the Q's divide out, leaving us with just 1. So we factored that out. How could I check it? Multiply through the brackets and see if I get to the same place. Okay, H, here we go. This one only has 2 terms, but gosh, they're long. Look at each of these terms. They all have an X's, Y's, and Z's in them. Well, 64 and 32, I can factor a 32 out of both of those. For the X's, they both have at least an X to the 4. They both have at least a Y squared. And they both have at least a single Z. 64 divided by 32 is 2. I'm dividing 4 of the X's out, leaving me with 2 of them. I'm dividing both of the Y's out and the Z out. So that's it. My next term, 32 divided by 32 is just 1. I'm dividing all 4 of the X's out. I'm dividing 2 of the Y's out, leaving me with 2 left over. And I'm dividing 1 of the Z's out, leaving me with 3 left over. Okay, let's keep on rolling. Here's I. I is a little bit of a weird one. In the past, when you saw something like this, you would say, oh, I know what I need to do. I need to multiply through the brackets. Let's do it. Let's multiply through the brackets and then simplify our like terms. But that's not what we're trying to do here. We're actually trying to factor. So I'll say, is there anything in here that you notice that is the same in both of these? Anything that's the same in both? Well, yeah. They both have an x minus 2. They both have an x minus 2. And it turns out that we can actually factor out That whole piece, we can factor out that whole piece. So what I'm going to do here is get rid of this so you can see what's underneath. The common factor doesn't have to be a single term, like a regular number or an x or a y. It could be a little more complex than that. It could be an expression. So if you think about 3xy minus 2y, you would say, oh, I can factor out a y out of both of them. And that leaves me with 3x minus 2. I can divide that y out of both of them. But what if y wasn't just y? What if y was replaced by x equals 2? What if y was replaced by x equals 2, just like we have up here? Well, we could factor out that entire thing. We could factor out the entire thing. Let's divide an x minus 2 out of each term. Now I'm going to have to put some brackets around it so I can see that I'm dividing out that entire piece. So my first term, 3x times x minus 2, I'm factoring out the entire x minus 2, and all I'm left with is 3x. My second term, I'm factoring out the entire x minus 2, and all I'm left with is minus 2. There we go. We've actually factored out a whole piece instead of just a single bit. Now, if you looked at this and said, okay, did I do this right? Could I get back to the original thing? Yeah, you could check by saying, I'm going to take this entire bracket and multiply it by that, and then this entire bracket and multiply it by that. Normally we're used to multiplying all the pieces out, and you could do that if we were trying to simplify. But that's not what we're trying to do right now. Right? We're trying to factor. We're trying to go the opposite direction. Okay, let's try a few more. I'm going to drag in a few other ones here. Where I put them may not match on your sheet, so just please be aware of that. Okay, this is going to be a little bit different. So I do want to practice our factoring of big chunks out. So let's start by doing J, because that's actually going to do the same thing. We're going to have to factor out some big chunks. So here we go. So I notice that in each of these I've got a 2x minus 5 and a 2x minus 5. So both of them have a 2x minus 5. I can actually factor out that whole chunk, the whole thing. Sorry, 2x minus 5y, I should have said. 2x minus 5y, I'm going to factor out that whole piece. What's left over for my first term? 2x is left over when I divide that out. What's left over for my second term? Negative 3y is left over for my second term. So I factored out that entire chunk. What about k? Common factor. Well, 2 and 3, the only common factor I've got for them is 1. So that's not super helpful. Let's think about it this way. Let's take kind of a different tactic here. And this is something we're going to use in the future. That's why I want to show this to you. I noticed that my first two terms both have an x that I could factor out. And my second two terms both have a y that I could factor out. So let's do that. Let's take an x out of my first one. And I'm left with 2a minus 3b. Let's factor a y out of my second one. And I'm left with 2a minus 3b. Aha! Oh, gosh! The 2a minus 3b is now a common factor. I can factor it out of my first thing and my second thing. So let's do that. Let's pull out, divide out a 2a minus 3b. What's left over for my first one? Only an x. What's left over for my second one? Only a y. You may wonder why I'm doing that. All that will become clear later. This is going to be useful to us in our later skills, but I just wanted to show you that kind of ahead of time. So that's J and K. What we did in K is called factoring by grouping. Again, we'll see that again in a couple of days. Finally, we've got L. For L, we're actually going to change the order, which you're allowed to do. As long as we keep our signs organized, we can change the order. So here's what we're going to do. Let's change the order around so we keep our x squared in the front, and then we have our minus xy next. And then we have our minus x, and then we have our plus y. So I'm going to change that order around. Let's look at my first two terms. I notice that I can factor out an x out of each of those. My second two terms, I can factor out nothing. But I could take out a negative 1, I suppose. So my first term, let's take an x out. What does that leave me with? Well, I got an x and a y. This one I'm going to factor out a -1. So divide both of these terms by -1. When you divide something by -1, it doesn't change the thing except to change the sign. So this is now going to be positive x and negative y. And oh, would you look at that? They both have an x minus y in them. So I can take out the x minus y, divide it out of my first term, I'm left with just an x. Divide the x minus y out of my second term, I'm just left with a -1. And again, those are a little funky, and you may be like, like, why am I doing this? I don't understand yet why we're doing this. All will become clear, I promise. But this is the skill we need to practice first so that we can start to put it to work in ways that are functional for us in order to find the zeros, the solutions of quadratic equations. Okay, so that's it for our common factoring. Common factoring today is our goal. Can you identify the common number that needs to be divided out of each term? Can you find the biggest common factor that can be divided out of each term? Can you write it out front and then divide it out of each of these pieces and see what's left over? That's what we're doing for factoring. Let's go for it. Here's some practice. Give it your best shot and ask if you need a hand.